Hey everybody, this is your 7.4 Math Excel video, and our topic is exponential models in recursive form. So before actually getting into the problems, let's just talk a little bit about the notes. Explicit uses substitution and exponents. Implicit uses previous terms and subscripts, and implicit is related to recursive, which has to do with repetition. So a sequence has commas like 1 comma 2 comma 4 comma 8. Series has addition like 1 plus 2 plus 4 plus 8. Now when we talk about specifics, arithmetic sequence has a common difference. Like on the sequence or pattern 2, 4, 6, 8, the difference is 2. You can either think 2 plus 2 is 4, 4 plus 2 is 6, etc. Or you could say 4 minus 2, 6 minus 4, 8 minus 6, etc. So the arithmetic sequence is when you're either thinking about adding or subtracting the same thing. Now a geometric sequence has a common multiplier, or you could think ratio. So in the example, I have 1, 2, 4, 8. You're multiplying 2 to each term. 1 times 2 is 2, 2 times 2 is 4, etc. So that's how you can think of it as a multiplier. Now, as a ratio, that means a fraction, and you do basically right over left. 2 over 1 is 2, 4 over 2 is 2, 8 over 4 is 2. So you have a common ratio. Okay. Now the normal formula for an explicit is an equal a1, which is the first term, b to the n minus 1. So an example would be an equal 9 times 4 to the n minus 1. We usually use n as the variable instead of x. On the recursive formula, that's the one that has subscripts and previous terms. So we have an equal b to the an minus 1. And so an example, this definition always has to have two parts. The first one is the initial term, like a1 equal 9. And then the formula is an equal 4 times a to the n minus 1. So, of course, you can write any sequence either of the two ways. Okay, so there's a couple of notes with it. Now, on your first Math Excel, by the way, this is a really short Math Excel assignment, only 4 questions. The table shows the number of visitors to a web page over several months. Write the explicit and implicit formulas. So here we have month as 1, 2, 3, 4, 5, and visitors 20, 40, 80, 160, and 320. So when we do our explicit, we notice that our first term is 20. Our difference, well really our ratio, is 2, because you're multiplying 2 to everything. Or you could think 40 over 20 is 2, etc. So b is 2. So when we write this, this would be 20 times 2 to the 0, because anything to the 0 power would be 1. 20 times 1 would be 20, and that worked. And then for the second term, 20 times 2 to the first. So 2 to the first is just 2. 20 times 2 is 40. And then on this one, 20 times 2 squared. You think 4 times 20 is 80, and so on. So that means your formula would be 20 times 2 to the n minus 1. On the recursive, that's the one where you have subscripts, and it says an equal b times a to the n minus 1. So again, we know the first term is 20, and then we have 2 times a to the first. So basically 2 times 20 gives you 40, and then 2 times a to the second. So this is a to the second, 2 times 40 gives you 80, and so on. So your formula is A1 is 20, AN is 2 times the previous. So that means 2 times a to the n minus 1. Okay, on our next question, they say the function y equal 20 times 5 to the x models the jackpot y in dollars on a game show that has been on the air x weeks. Write a recursive formula. Okay, so again, recursive has subscripts. That's an equal b times a to the n minus 1. Our initial is 20 because it's always the number in front when we have exponential functions. And then we just got to figure out how things work out. Our base is 5, so we're going to say 20 times 5 is 100. And then on the next one, if we put a 2 there, it'd be 20 times 5 squared. Now you could think of that as 20 times 25, and that's 500. So basically we're just multiplying that by 5. It's like an extra multiplication of 5. And then on the next one, a to the 4th is 20 times 5 cubed, like 20 times 125, which is 2500. So again, if you just think of it as 100 times 5 is 500, 500 times 5 is 2500, and so on. So that means our formula is A1 equal 20, AN equal 5 times the previous term, a to the n minus 1. On our next one, it's a multiple choice. It says you invest $600 in a savings account that pays 6% annual interest, compounded quarterly, and write a recursive formula. So just think about what you know. You know your initial amount is 600, and we want to write a recursive formula. The annuity formula is A0 equal M, which is your amount basically, and then AN equal 1 plus your rate as a decimal. So if you see 6%, you put 0.06. Divide by n, which is your number of times compounded, and quarterly is 4 because you know there's 4 quarters in a dollar. And compounded quarterly means 4 times a year. And then a to the n minus 1, which is the previous, and then plus p, which is your initial amount, just like m. I don't know why they use so many letters that mean the same thing, but you know that's just going to be the same number. So what we have is 1 plus 0.06 over 4, a to the n minus 1, plus 600, which is your base amount. Now, in multiple choice, it's not in that form. They want you to multiply, they want you to divide this out and add. And so if you do that, you get 1.015 in front, and then the rest. Now, on the multiple choice, they kind of make it obvious. You know you're going to be adding in our case because we're paying interest. Your account is growing, so this would be growth. And so if you see some choices with minus 600, it wouldn't be that. And also, you have a growth rate, not a decay rate. So what that means is it's not going to be 0 point something. It's going to be 1 point something. So then you just rule out your choices, and you know you get it. On your last one, we have an accountant buys a new computer for $2,000. Each year the value decreases by 50%. Write a recursive and explicit formula. So just using common sense, 2,000 times a half would be 1,000, and then cut it in half again, that's 500, and so on. So for your explicit formula, you start with 2,000, and then you have 0.5 to the n. Remember, explicit uses exponents. So this first term would have been 0.5 to the first, second term 0.5 squared, then 0.5 cubed, and so on. Okay, and then for the recursive formula, you don't start with the 2000, you put the 1000 because this has the first term, which we said earlier was 1000. So the recursive formula has A1 is 1000, and then AN equal half of the previous term. So just like that. All right, hope that helps.